What if I told you about a technology that is so successful, so absolutely fundamental to everything we do online, that its ultimate goal is to completely disappear? It sounds like a paradox, right? Well, let's get into it.
Because that is exactly what's happening with virtualization. I mean, this is the engine that makes the cloud go, and it's on a journey to become so good, so efficient, that it just fades into the background and becomes totally invisible.
To really understand how we got here, we've got to jump in a time machine. We're going back to an era when computers were just colossal, they were unbelievably expensive, and honestly, super inefficient.
So, picture this. It's the 1960s. We're in the world of big iron. A single mainframe computer was a multi-million-dollar machine that took up an entire room. And you couldn't just sit down and use it. Nope. You'd hand over a stack of punch cards, and then you'd wait, sometimes for hours, just to get your result.
But here's the really mind-blowing part. The waste. These incredible machines were constantly just sitting there, waiting for slow stuff to happen like reading a card or printing a page. And that meant the CPU, the multi-million-dollar brain of the whole thing, was doing absolutely nothing for up to 90% of the time. Just think about that.
Now, a massive problem like that is just begging for a clever solution. And that solution didn't come from some big top-down corporate plan. It came from a small team of brilliant researchers at an IBM lab who had this kind of wild, counterintuitive idea.
They were building on this idea of time sharing, which basically just let a bunch of people use one computer at the same time. But the team on the CP40 project made this huge conceptual leap. They asked, instead of just sharing the computer, what if we could give every single user their own fake private computer? And just like that, the virtual machine was born.
And the magic trick that made this all possible? A brand new piece of software called a hypervisor. You can think of it like a master conductor for an orchestra. It sits right on top of the physical computer hardware and it carves it up into pieces, creating all these isolated virtual machines and making sure they all play nicely and share the real hardware.
So, you're probably wondering, how does this not create total chaos? Well, it's all thanks to this elegant little dance. See, the operating system inside the virtual machine isn't allowed to touch the real, sensitive hardware. Anytime it tries, the processor traps that request and immediately hands control over to the hypervisor. The hypervisor then safely performs the action for the virtual machine. It's this beautiful illusion of control.
Okay, so for decades, virtualization was kind of this niche, mainframe thing. But then, let's fast forward to the late 1990s. The entire tech world was facing a totally new kind of inefficiency, and it created the perfect storm for virtualization to have this explosive comeback.
Companies were buying cheap servers by the thousands, but here was the problem. To keep applications from conflicting with each other, they just put one app on each server. This created something called server sprawl. We had these massive data centers packed with machines that were barely doing anything, running at maybe just 15% of their capacity. Virtualization changed everything. It let you pack dozens of those apps onto one machine, cranking utilization up to 80% or even more.
This was truly virtualization's phoenix moment, rising from the ashes. But there was a big catch. The cheap x86 processors that everyone was using, well, they just weren't designed for this. So companies like VMware came up with this incredibly clever hack called binary translation. They would literally rewrite bits of the operating system's code in real time to make that whole trap and emulate model work on hardware that wasn't built for it. And the impact on business? It was just staggering. By piling servers together, companies slashed their total cost of ownership. We're talking hardware, electricity, cooling, even the building itself, by an average of 74%. This wasn't just a small improvement. It was a complete revolution in how data centers were run.
And that revolution set the stage for what has become the defining debate of the modern cloud era. It's a battle of architectures, the heavyweight virtual machine versus a new, super lightweight challenger, the container.
And this really is the perfect way to think about it. A virtual machine, a VM, is like a fortress. It's a whole simulated computer with its own operating system and thick, hardware-enforced walls around it. A container, on the other hand, is part of a swarm. It's this tiny, fast unit that just packages up an application and its needs, and it shares the main computer's brain, the kernel, with all the other containers.
So the trade-offs here are crystal clear. VMs are big, we're talking gigabytes, and they take minutes to start up. But in exchange, you get that rock-solid, ironclad security. Containers are tiny, megabytes, and they start up in seconds. They're absolutely perfect for modern apps. But their security model, well, it relies on that shared kernel, which is a much weaker fence than a fortress wall.
And it's this exact conflict, the fortress versus the swarm, that constant tug-of-war between the need for security and the demand for speed that is pushing virtualization toward its final and ultimately invisible form.
Because it turns out this whole VM versus container debate was the wrong question all along. The industry isn't picking a winner. What we really want is to have our cake and eat it too. We want the absolute hardware-level security of a VM, but we want it with the ridiculous speed and density of a container. And you know what? We are actually getting it.
This best of both worlds future is being delivered by a whole new generation of technologies, and you shouldn't think of them as separate choices, but more like a spectrum of solutions. This is where the line between VM and container just completely blurs into nothing. So let's break them down.
First up, we have the most pragmatic solution today, MicroVMs. Think of projects like AWS Firecracker, the tech behind Lambda. They took a traditional VM and just stripped out everything, all the junk you don't need. No BIOS, no generic drivers. What's left is a minimalist fortress that can launch in milliseconds. It basically wraps each little workload in its own tiny, super secure hardware box. It's the perfect bridge between the two worlds.
Then, you've got the really purist approach, Unikernels. This is even more radical. Instead of running on a big general-purpose operating system, you compile your app with only the bare minimum OS libraries it absolutely needs to function. That's it. It creates this tiny, incredibly fast, and ultra-secure little package, because all the extra code that could be a security risk is just not there. It's the theoretical peak of optimization.
And finally, we have the visionary leap, WebAssembly, or WASM for short. Now, WASM started in the web browser, but it's becoming a universal format for code. It runs inside a super secure sandbox that doesn't care about the operating system or even what kind of CPU you have. This is the next level of abstraction. We stop thinking about virtualizing machines and start thinking about just running code securely, anywhere.
So this is the big takeaway. Virtualization isn't dying at all. It's winning so completely that it's just becoming a commodity. The hypervisor is no longer this big, complicated thing you have to manage. It's becoming an invisible feature that platforms like Kubernetes can just call on whenever they want, instantly giving an application exactly the right amount of security it needs for exactly as long as it needs it.
And that leaves us with one last, really fascinating question to think about. As the virtualization layer itself just fades into the background, all of the importance and all of the complexity moves one level up. The real challenge for the future won't be about managing VMs or containers anymore. It's going to be about mastering the incredibly powerful and incredibly complex control planes that will orchestrate our entire digital world.